So welcome to the first semester of organic chemistry. And before we start talking about principles and understanding the background for how chemistry works, and what things you might already know and what things might be new to you about organic chemistry, let's start by talking about what is organic chemistry. So organic chemistry is the chemistry of molecules that are primarily made up of carbon. While that might sound kind of limiting, there are actually millions of compounds that are considered organic compounds, and really on the order of hundreds of thousands of compounds that are outside of organic chemistry. So even though we're basing things off of primarily one particular element on the periodic table, a lot of other elements do show up too. We'll commonly see things like hydrogen, nitrogen, oxygen, halogens, fluorine, chlorine, bromine, iodine, boron, aluminum, phosphorus, sulfur, and a few other elements here and there. But these will be common ones that we'll see a lot of. And in each case, if they're bonded to carbon, that will make it part of organic chemistry, and those will make those chemicals organic chemicals. So where in everyday life do you run into these things? Really, organic chemicals are going to be found in pretty much every part of life. Anywhere from clothes. Our clothes are made up of just about entirely of organic chemicals. Foods. And in fact, if you didn't know it already, cooking really is just a form of chemistry as we're doing chemical changes to food. Medicine. And things like fuels. All of these things are organic chemicals or organic chemical based. And we'll see from time to time throughout the course how organic chemistry relates to some of these different areas. So some other background information before we get too far. I have some certain things that I'll say over and over in class. Sometimes I'll call them, in a way, a class mantra. But really they're either questions or they're things that will help us remember things in organic chemistry. So to start off with, I'll give you a few of these kind of common things that you'll hear me say. One of them is, anytime I ask you why in organic chemistry, the answer is nearly always lower energy. Okay, that's why things happen in chemistry. So one of the things I tell my classes when I meet with them in person is that if you ever hear me say why in class, you can just yell out lower energy, even if you're doodling or not paying attention or texting your friends or something like that, though I don't encourage those things during class. But if you ever hear why, the answer is usually lower energy. Now the interesting question, and maybe more interesting question, is why is it lower energy? And that's what the thing we'll try to explain throughout the course, try to help see why certain things are lower energy and why certain things are more stable. Another one, once we start getting into synthesis problems and a lot more reactions, which won't be until chapter 7 is when we really start reactions, is what do organic chemists want to do? And my answer for that is control everything. And that comes really back to synthetic methodologies. And if we're trying to make certain molecules, a lot of times we'll find them as a natural product first, and then we want to try to find out how to make that molecule in the lab. Or we want to make a similar molecule with some subtle changes in it. And to do that, we need to be able to control exactly what position new groups add to, exactly what stereochemistry they'll have. So if I ever ask what do organic chemists want to do, the answer is control everything. And the last piece really comes down to something that I've heard over the years that I really don't like, and that's that some people think that organic chemistry is primarily about memorizing. I don't think that organic chemistry taught correctly is about memorizing. Like any new subject you learn, you do need to learn the language of that subject. Organic chemistry is like that. In fact, there is quite a bit of language around organic chemistry that we need to learn throughout the year. But I don't think it's any more about memorizing than any other subject is. In the end, there are 5 basic principles that we can use to explain just about everything in organic chemistry. And they spell out a mnemonic that can help us remember it, that there really are 5 areas. So as we go through Organic 1, we'll see all but one of these. One of them will only be introduced in Organic Chemistry 2. So A, we have acids and bases. So I'll usually write that as acid-base. R is resonance, which is all about delocalization and stabilization. E is electronegativity and polarity. And those two are closely tied to one another. The second A is aromaticity. And this is the one that you're not going to see until second semester. Aromaticity is in Organic Chemistry 2. And the last one is sterics. And sterics really is just has to do with size, and that bulky things don't want to be near each other. But really, most of organic chemistry can be explained with these 5 topics. And that makes it a whole lot less about memorizing and more about being able to apply concepts. And that's what makes organic chemistry valuable to you. Because I realize that most people that take organic chemistry are not going to be chemists. And so a lot of them feel like there's no reason I have to take this. I'm just taking this course because of something else that I want to do. Maybe I'm a biology major, or I'm a pre-med or some kind of health sciences, and I just have to do this to jump through someone's hoops. I don't believe that that's true. I think that there's actually really strong reasons that you need to take organic chemistry, and none of it really is about content knowledge unless you're going to be a chemist. What it really is about is it's really about learning problem solving in different kinds of ways. And the types of problems that we solve in organic chemistry are different than you'll solve in just about any other field. So the problem solving kind of things that we're going to do is we're going to look at mechanisms. And mechanisms really are how reactions happen. And then the other one that's really valuable in organic chemistry that you don't see in very many other subjects are the synthesis type problems. And this is starting with one molecule, molecule A, how you go through several steps, sometimes 2, 3, 4, 5, 6 steps to get to molecule B. A big part of the value of these synthesis problems is that you have to think forwards and backwards. A lot of times the easiest place to start is to start at B and go backwards a step or two, thinking about how we can add certain groups on, and then start going forwards from A and finding out where they meet in the middle. And these are the reasons that most of you, if you're not a chemistry major, that most of you are being asked to learn organic chemistry. It's really to learn advanced problem solving, and that kind of problem solving you'll use no matter what you do in the future, whether you're a chemist, whether you're an engineer, whether you're in health sciences, whatever it is that you're doing.